So Earth's magnetic field reflects solar winds and cosmic rays. Cosmic rays are particles that have high energy. So what causes magnetic force? So the reason why Earth's magnetic field does this is because there's an a magnetic force on these charged particles when they move through Earth's magnetic field. So when they move through Earth's magnetic field, there's a force on them, and that force causes them to move.
I have a question.
Yeah.
Is that what MRI's on?
Similarly, yeah. You put yourself in a magnetic field, and it's the motion of the charged particles through the magnetic field. Yeah.
If I were to eat $1.15 spare change,
You're stealing my joke.
I said it first. You stole the MRI thing. If I were to eat a bunch of coins and go into the MRI, what would happen?
No. Well, that's kind of what we're going to look at with the MythBusters video today. The MythBusters video is can tattoos explode in an MRI machine? Because the ink is slightly magnetic, and so could that cause some sort of force to do something to your arm if you're in a magnetic field? Yeah, the iron fillings. All right, let's see. Do you have something about the direction of Earth's magnetic field? No. Okay. I want to add one more thing. So last thing here for the questions. What is the alignment of Earth's magnetic field? So Earth's magnetic field works like a bar magnet. So what pole is at the North Pole? It's a South Pole. So Earth's magnetic field is backwards. Because why do compasses point north? Because they're pointing to a South Pole.
Why don't we just make compasses backwards?
For real, because someone made that up.
So you're going to find that there's lots of stuff like that in this electricity unit. So we got, the reason is we got electrons wrong.
We can still change it.
We got electrons. Okay, physicists don't change things. We got electrons wrong. So electrons are what move, and we thought that they were the positive charges, but then we found protons, found they were the positive charges. The long story short, we thought it was the positives that move, but it's not. It's the negatives that move, which means everything's backwards. So we think of it as forward positive direction, but things actually go backwards. So we think of North Pole points north, but it's actually pointing to a South Pole because of how the fields travel. So because you'd have to change everything. All right, clarifying. Quiet, y'all. I'm going to read it, and I'll also post this on Schoology.
So, for clarifying, a charged particle at
Guys, hush.
a charged particle at rest will not interact with a static magnet.
Good. So this is a big idea here. I talked about what causes magnetic force. I want to make sure you understand that if the particle does not move, it does not feel a force. There has to be a changing movement in order for there to be a force. So it can't just, if you just put a charged particle in a field, nothing will happen. If you throw a charged particle through a field, it'll move and create a force. Okay, good. What else?
The magnetic, is it declination? Is that how you say it?
Declination.
Declination. It's like when the compass is not generally pointed to north. The discrepancy between the orientation of a compass and true north is known as that. So like, I don't know.
Where a compass points is not the north geographic pole. It points to an area that's in the Hudson Bay. That's where the magnetic field is. This is kind of bizarre. Earth's magnetic field moves. It doesn't stay stationary.
I'm sorry.
No, go ahead.
I was just like, if I go north, will I end up at the Hudson Bay?
Yes, like if you follow a compass to north, so like if you get to the point where the compass just spins around, right? You would be in like the Hudson Bay. You wouldn't be at the North
I
Pole.
dig down and then I'm going to center the earth.
Yeah, there you go. So there's some interesting stuff there. Here's another interesting thing. The North Pole. So we just said that the South Magnetic Pole is at the North Pole. It hasn't always been that way. Earth's magnetic field, rock samples suggest that Earth's magnetic field flips regularly. So like at some point in time in your lifetime, because it's supposed to have happened by now. It hasn't, like it was supposed to happen several thousand years ago and didn't. Wow. So it might happen any day. That Earth's magnetic field would flip. And so all of a sudden compasses would point south instead of pointing north.
So what do we do with the compasses?
Huh?
Will that happen like in an instant, or will that like,
Yeah, we're not sure. We're not sure. Like it seems like it happens pretty quick because Earth's magnetic field can shift pretty quick. But it changes over time. Yeah.
So that would mean that north would actually point north and south would
Yes. Yeah.
All we have to do is just wait for the
Yeah. Just wait for it to flip, and then we'll be good. All right, and you talked about the declination one. Okay, good.
That's all I got.
All right, summarize.
So I had a charged particle moving through a magnetic field experiences a deflecting force. The force is greatest when the particle moves perpendicular to the magnetic field lines.
Sorry.
And I had Earth's magnetic field reflects solar winds and cosmic rays away from the atmosphere.
Good. So I put a star next to this part about the force is greatest when it's going perpendicular. So it can go at different angles, but the force is largest when it's perpendicular. If it's parallel, the force is zero. Because there needs to be a difference between the charge and the field. So the big idea for this section is what a magnetic force is and understanding how Earth's magnetic field works. So force is caused by moving charged particles through a field. Charged particles from the sun do this in Earth's magnetic field, and they get moved to different poles. This is what causes the northern lights. The northern lights are caused by magnetic force pulling those charged particles to the poles. So that's where you see. Okay, any questions on this section?
Isn't that when like the electrons reach a higher level of energy and that's what also causes them?
So the electrons absorb, so the atoms in the atmosphere absorb the particles from the sun. They increase their energy level to a higher level, and then when they jump back down, they give that energy off.
Okay.
Yep.
Don't the northern lights make noise too?
Yeah, there is like a sound associated with them.
Northern lights.
Can I? All right, you guys can have a seat.
Just a